Okay, here's the information on call by value parameter passing. So, as I said up in the previous lecture, that the syntax for this is simply that for the declaration just looks like, proc p x is s, so we don't have that keyword var in there. So the rule is identical with the var for the declaration rule is identical, but you just take out the var. And so if you remember, all you're doing is you're essentially storing in the proc environment under the name P the information about P, which is its body, its formal parameter name, the environment, the variable environment used at the time that the declaration was made, and the procedure environment in place at the time that the declaration was made. So the rule's identical. Now, here's the call under the CVV scheme, and I don't know. He has this other information here that I've blacked out that is the rule that allows a recursion. It's actually quite straightforward to add recursion because all you need to do is make sure that the environment that you evaluate S in also knows about P. So you need to put a more, I guess I'm saying, I need to say it up here. The environment where you're saying, okay, P gets mapped to something, and then there's an ENVP here, but you need to update that one so that it has the same information. It knows how to call P. See, I apologize. If you try to call P with this rule, when you or evaluate P, with this rule, the ENVP does not know about P because it's the one that we encountered at the time of the declaration. But you could modify this so that it knows about P and put that one in here and use the regular ENVV one there. And then as you're evaluating S, if you encounter another call to P, and i.e., if you encounter a recursive call to P, you'll be able to handle it because it will be in the environment. So, all right, let's skip that. I left that out because it just complicates things, but it's actually not that hard to do. So the calls look like, call P with an A expression. And so what are the steps? So what are the steps to set up, to interpret this rule here? Well, what is this rule telling us we need to do to evaluate a call to P under call by value? First thing we do is, look up P in ENVP. So that's what this does. This is, okay, ENVP, and we get back S, and we get back so we get back the body, we get back the formal parameter, we get back the variable environment, and we get back the procedure environment. And these were the two that were in place at the time that P was declared. Now we're at the call, but we need to use those to maintain static scoping. So we have S, X, ENV prime, and ENVP prime. And these are the environments in place when P was declared. So now what we do is he separated this by a comma here. This is a separate thing. He's telling you how to get the value V. So we're passing the argument A, so we need to evaluate A in the current store that's in place at the time of the call. So we evaluate A, we get back some value V. And so then V is going to be used up above when we say what store do we want to evaluate in. So what store do we want to evaluate in? The one where L, which is the next location, is bound to V. So what do we do here? We bind X, the former parameter, to L. So again, let's just ignore this part for now. And so what's going on here? Well, it's almost like a kind of like a temp variable has been allocated. That's what here is. We get the a new location, which is the next available one. And then remember the formal parameter name is X, and so we set X to point to this new memory location. And so the variable environment for now, when it reads S, and whenever it sees one of these X's hanging around, it's going to say, oh, okay, I know the meaning of X. X points to the location L. But we also have to, over here, what we're doing is we're saying, oh, and by the way, L is pointing at the value V, which is what we got from evaluating A. So it's a little bit like allocating a new storage space and then figuring out what A is and making so this is evaluates to V. We make the new location point to the value V, and we make the former parameter X point to that new location for the purposes of evaluating this S. Now, what's this part here doing that that I blacked out? Well, that part there is his bookkeeping. He has to make sure that he doesn't, for example, S could be a begin-end block. You could start allocating, and with variable declarations in it, you could start allocating more storage. And if you don't update this to point to the new location so that the next points to new, and remember new is really, new L is just an abbreviation for L plus 1. So he's making the next point one memory location ahead so that it's pointing at the correct next location. If there were variable declarations in S and we didn't do this, what would happen is we would clobber the variable that we just allocated for to hold, we'd clobber the location that we just allocated that X points to. We would reallocate it, and then we might use it in a bad way. So the third step is, so I said up here, okay, evaluate A, that's what gives us this. That's this part here. And that gives us V. And then look up the next available location, and that's what's going on here. We look up the next available location in the current environment. And this is going to be a temporary location in memory, so that now ENVV points X to L and STO points L to V, which was the result of evaluating A. So the result is that every time we look up X in ENV, it will be bound to L, and location L has the value V in the store. That's how we did that. We made L point to V. And then this is a little bit about the bookkeeping. So here's something for you to try on your own and to see if you understand is to try evaluating these programs using CBV. So you've got like this one, you got X and Y declared, and then this has the same. And then the proc is, the definition of P is the same, and you need to see if you can figure out like the difference between calling it with Y and the difference of calling it with X plus Y. Now, interestingly, I think this one, so the question here is for you to, what are the values of loc 0 and loc 1, assuming you start with the empty store and the empty environments. What are the values of loc 1 and loc 0 and loc 1 after this program is run? Because, this is going to be your loc 0 is going to be allocated first, and then you're going to get loc 1 is this one. And so X is loc 0, Y is loc 1. And so what does this do? Now you might also try this by, this one also makes sense under call by reference. So if instead here we had that little keyword var in there, then this would be a valid program under call by reference. And you could try evaluating this one under call by reference, and it will give you back a different value. And you'll see how that works. So that's a interesting. When I wrote it down, I was just saying, oh, how about doing something where you try these things out? But I didn't realize this one actually is a program that under call by value and call by reference will evaluate differently. Okay, so now we are up to call by name. And I think I'll stop there and we'll do another one.